Okay, starting lesson 3.4, graphing linear equations in standard form. All right, now students often find these equations to be very difficult to graph, but let's see how simple graphing these is. All right, graph the equation y equals 4 for part A. All right, when you're graphing this equation, just know that every point has a y value of 4. Okay. So where are my points on the grid where the y value is 4? Okay, well, there's one. Okay, that's 0, 4. All right, there's another one. That's 5, 4. There's another one. That's 4, 4. Sorry, negative 4, 4. There's another one. That's negative 8, 4. All right, it's all these here. All of these points have a y value of 4, and everything in between. Okay? You could have decimals for coordinates. That's okay. All right, so there is our line then. Passes through all those points. All right, for x equals negative 2, how do you graph it? Well, just ask yourself, where are all the points where the x values are negative 2? Well, there's one. That's negative 2, 0. There's another one. That's negative 2, 4. There's another one. That's negative 2, negative 3. There's another one. That's negative 2, negative 8. All right? So all these points here have an x value of negative 2. All right? And all the ones in between. Okay? So your line passes through all those points. All right, it's as easy as that. Going on to the next example. Okay, for example 2, it says graph using the intercepts. All right, so how does that work exactly? All right, well, intercepts are simply where the line crosses the x or the y-axis. All right, so it's crossing one of the axes. All right, so we have the x-intercept to start with. And how do you determine that? Well, it's really simple. We set the opposite variable equal to 0. Plug it in and then solve for x. So we have 3 times x plus 4 times 0 equals 12. All right, that's gone because that's 0. So we have 3x equals 12. Divide by 3, and x is equal to 4. All right, so make sure to write your coordinates correctly. X is 4, y is 0. All right, that's a very important piece of information. You need to figure out the y-intercept as well, meaning where the graph crosses the y-axis. All right, this is where the graph crosses the x-axis. All right, so once again, I set the opposite variable equal to 0. So I end up with 3 times 0 plus 4 times y equals 12. 4y equals 12 divided by 4. Y is equal to 3. So I end up with 0, 3 for my y-intercept. All right, another important piece of information. Now I could graph the equation using the intercepts. The x-intercept is 4, 0. Once again, that's where the graph crosses the x-axis. The y-intercept is 0, 3. Once again, that's where the graph crosses the y-axis. All right, with those 2 points, all you need is 2 points to graph a line. So with those 2 points, I can graph my line. Just a rough sketch there. All right. On to the next example. Okay, you are planning an awards banquet for your school. You need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 6 people, and large tables seat 10 people. The equation 6x plus 10y equals 180 models the situation. Okay, they already did that work for you. That's nice. Where x is the number of small tables and y is the number of large tables. Okay, graph the equation, interpret the intercepts. All right, so we're going to first figure out the x-intercept, just like we did before. And so we set y equal to 0. Plug it in, and we have 6x plus 10 times 0 equals 180. That's gone. I have 6x equals 180. Divide by 6. and x is equal to 30. All right, so the x-intercept is 30, 0. Make sure not to mix up those two numbers. Then I have the y-intercept. To figure that out, I set the opposite variable equal to 0. All right, so I have 6 times 0 plus 10y equals 180. So I have 10y equals 180. So y is equal to 18. So my y-intercept is 0, 18. Okay, I'm going to graph this equation using the intercepts. Okay. Since I'm talking about seats or tables, I can't have negative tables in this type of problem because that wouldn't be a real-world application then. So, going to go up, let's see, I have 30 here, 18, I'm going to go by, let's go by 2s, or 4, I'll go by 5s. All right, it's your choice how you want to construct the graph. All right, yeah, that works, okay. So now 5, 10, 15, 20, 25, 30, 35. Okay, my x-intercept is 30, 0. And my y-intercept is 0, 18. So I'm right here. All right, and then there's my graph. Okay. All right, then it asks you to find 4 possible solutions in the context of the problem. Okay. Well, I already have 2 solutions. Okay. I could have 30 small and 0 large. Then I could have 0 small and 18 large tables. All right, but there has to be some in between. All right, so how do you figure that out? Well, if there are, let's say, 5, let me go to this value here. If there are 5 small tables, okay, then how many large tables should there be? Well, I just plug it into the equation. 6 times 5 plus 10y equals 180. So I have 30 plus 10y equals 180. Subtract 30. I get 10y equals 150. Divide by 10. And y is equal to 15. All right, so there would have to be 15 large tables then. If there were 5 small. All right, what about if there were 10 small tables? Then how many large tables do we need? Well, you do the same thing again. Let's get a little more space here. So I have 6 times 10 plus 10y equals 180. So I get 60 plus 10y equals 180. Subtract 60. 10y equals 120. Divide by 10. And y is equal to 12. So I'll need 12 large tables if I have 10 small. All right, so that's answering part B. Find 4 possible solutions in the context of this problem. Context just means the situation that you're in. All right, and there are my 4 possibilities for the types of tables I need. All right, that's all there is to this problem. Now you can begin the assignment at the bottom of the page. Make sure to ask questions if you have any.